In this video from ITFreeTraining, I will look at the USB-C connection and look at how it is used to display video. The USB-C connection is becoming more common and looks like it will become a standard for connecting devices in the future. The USB-C connection, more formally known as the USB Type-C connection, was first released back in 2014. It was first developed for USB, but as we will see later in the video, is now used for a lot of different connections. The Type-C connection is different from previous USB connections. First, it acts as a host or a device. Essentially, this means the same plug can be plugged into a host like a computer or used on the other end to plug into a device. The same connection is used on both ends, so it does not matter which end gets plugged into which side. The connection is also reversible. As you can see, it can be plugged in either way and will work the same. You don't need to worry about plugging it in the correct way. Just make sure that you are plugging it into a USB-C plug. To understand better how USB-C works, let's have a closer look at the connection itself. The USB-C connection is a 24-pin symmetrical connection, with 12 pins at the top and 12 at the bottom. Since the connection is symmetrical and not keyed like other connections, it can be put in either way. To understand how this works, consider the top row of the connection. Don't worry about what each pin means for the moment. I will go through that shortly. Now consider the bottom row of pins. These are similar to the above pins, however, are not in the same order. But look what happens when I turn the cable around. The bottom pins are now at the top. Some pins are the same and some are slightly different. Let's start from the outside and work our way in. To start with, consider the ground pins at the end of the connection. Electricity needs somewhere to go. The ground pins provide a path for the electricity to go to get back to ground or to essentially drain. For this reason, these pins can be swapped without issue. The next two pins are either transmit 1 or transmit 2, depending which way the cable is plugged in. USB-C uses differential signaling, and thus two wires are required to transmit. Using two wires to transmit means that both are affected by interference in a very similar way. This allows a lot of data to be transmitted down the wires at low voltage. Differential signaling is becoming very common with high-speed serial transmissions. You can see that if the cable is flipped, the top pins are still used for transmission. However, the only thing that changes is they become essentially lane 2 for any transmission rather than lane 1. When the cable is plugged in, the device will detect which way it is plugged in and flip the transmission lanes as required. Basically, if the cable is flipped, lane 1 will become lane 2 and lane 2 will become lane 1. On the other side of the cable are the receive wires. The same principle applies. The device will flip the lanes if the cable is plugged in upside down. The next pins are the power pins. Since these pins only provide power to the device, it does not matter if they get flipped or not. Following this are the configuration pins. These pins are very important. They first detect when the cable is plugged in. Next, they determine which way the cable is plugged in. It is important to know this information as it determines if the lanes need to be flipped or not. USB-C has the ability to change the signal and control which wires are used to transmit what signals. More on that later in the video, but the important point to take away here is that the configuration channel is used to determine what wires in the cable will do what and what protocols will be used. For the moment, I won't worry about what we can do. I will worry about what happens in the default case. The next pins are side bus mode. I will cover this more later in the video, but essentially, these pins provide a channel in the reverse direction. This is useful for protocols that need to return data, like the HDMI and DisplayPort audio return feature. The last pins of the connector are the USB 2.0 differential pair. These are essentially used for backwards compatibility with USB 2.0. If you use a USB-C connector to connect to USB 2.0 devices, the device will use these wires and a lot of the other wires will be disabled. For example, half the power and the other transmit and receive wires will be disabled since USB 2.0 does not use them. You can now see that by flipping the plug, most of the wire's functions remain the same. The device simply needs to recognize which way the cable is plugged in and flip some lanes accordingly. You may be thinking there are essentially 3 differential signaling lanes, 2 for USB 3 and 1 for USB 2. So how do we use USB-C for a device like DisplayPort, which needs 4 lanes to operate? When USB-C is operating in its default mode, you will have 2 USB 3 lanes and 1 USB 2 lane. These all are bidirectional in nature, meaning that they can transfer data in both directions. The 2 USB lanes are enough to support the USB 3.0 and 3.1 standards at full speed. The USB 2 lane is there for backwards compatibility. However, with devices like DisplayPort, the primary purpose is to transfer a lot of data and not require that much data be transferred back. For this reason, USB-C supports an alternative mode. Alternative mode essentially means that the wires in the connector can be changed from their default purpose to something else. Let's have a closer look. Alternative mode is essentially optional capabilities to support non-USB signals over a USB cable. Consider that you have a monitor, and this monitor has a USB-C port which supports DisplayPort, HDMI, and Thunderbolt. It is up to the manufacturer of the device to determine what they will support. So essentially, what we can do is plug in our video cable and a DisplayPort to USB-C cable. When the cable is plugged in, the monitor will sense a DisplayPort is on the other side of the cable. When USB-C detects DisplayPort is on the other side, it configures itself to use DisplayPort alternative mode. So essentially, one USB-C port on the monitor could support DisplayPort, HDMI, and Thunderbolt. You can understand why USB-C started to become very popular. Rather than having multiple ports on the back of the monitor, you could have one USB-C port that is automatically configured to use the connection that is plugged into it. In the case of the DisplayPort, it can use 4 lanes to send data to the monitor and 1 lane for return traffic. It is a simple matter to change the wires on the cable to accommodate this. Think of it like a passive adapter which remaps the wires inside the cable. With a USB-C cable, if alternative mode is used, then the wires in the cable can be remapped to perform different functions. You can see that using the USB-C cable gives you some options about what is displayed on the other side. However, this is not the only option it offers. USB-C can also offer options on other devices, not just the monitor. For example, consider that you have a laptop. The laptop has 2 USB-C ports. The USB port could, for example, have a USB converter hub attached. This converter hub would provide HDMI and USB ports. An HDMI cable could be plugged into the converter hub, which could be plugged into an HDMI monitor. You can see how much flexibility this can offer. Keep in mind that there are a limited number of wires in a USB-C cable, and thus the amount of data that can be transferred is also limited. If you start connecting multiple devices together, your experience may be affected by how much data is transferred through the cable. Although technologies like Thunderbolt and DisplayPort allow multiple monitors to be daisy-chained together, keep in mind that if you are running higher resolutions, for example 2 4K displays, and then try to add USB functions, this means there is a lot of data running over the one cable. If you are doing this, consider breaking the data up. For example, running video off one USB cable and USB off a different one. Given that USB-C can support a number of different technologies, it is important to understand what each port supports. In many cases, a port on the computer or device will have a logo or logos on it to display what it supports, but not always. In some cases, you may need to refer to the manual or simply plug it in and see if it works. If the port supports USB, you will see one of the following USB symbols. If the USB port is powered, the USB logo may be different. I say maybe because there is no guarantee that the logos will be the same on different devices or even be present at all. The port may also display logos to indicate which kind of graphics port it supports. Although this may seem complex at first, the point to remember is that both sides only need to support the same thing. Both sides will negotiate to determine what will be used. Typically, it is not uncommon for a display port on a video card to also support HDMI, or vice versa. Many monitors also have this ability, so you can see that the technology already exists for a single port to be used for multiple standards. You can see that USB-C, using the same port for many different things, has many advantages. In the future, we potentially will need to purchase fewer cables. A good USB-C cable can be used between different systems with different technologies. If USB-C takes off, the same cable could be used to connect a mobile device to a computer, connect the monitor to the computer, or connect to a USB device. The choice is up to you. You will no longer have to purchase particular cables for a particular need. This concludes this video on video displays and the USB-C connector. I hope you have found this video useful, and I look forward to seeing you in other videos from us. Until the next video, I would like to thank you for watching.